Hello everyone, and welcome. Today we're going to explore some essential tools for visualizing data, including bar, pie, and line graphs. We'll also look into geographic graphs to understand spatial data better. This is the first slide, so I just want to give you a quick overview of what's coming up. We'll start with the basics of different types of graphs and how they help us interpret information effectively. I'm excited to take you through this journey, so let's get started. Now, let's take a closer look at some common types of visual data displays. First, we have the line graph, which is great for showing trends over time. Next, there's the pie graph, used to illustrate parts of a whole, making it easy to see proportions. Then, we have the bar graph, ideal for comparing different groups or categories side by side. These are considered the main types of visual data displays. The key idea here is that they help us quickly compare groups of data and make generalizations about the information we're analyzing. In essence, these visuals allow us to see patterns and relationships that might be harder to spot just from raw numbers. So, what exactly are these visual displays? They are tools used to compare amounts, frequencies, or trends within data sets, providing a clear and immediate understanding of complex information. Now, let's connect this to geographic graphs. Geographic graphs are a specific type of visual display that map data onto geographic locations, helping us understand spatial patterns and regional differences. They're essential for visualizing data that varies by location, making them a powerful tool for analysis in many fields. So let's talk about the key feature of bar graphs. The height or length of each bar actually represents the data value or how frequently that particular category appears. This visual cue makes it easy to compare different groups at a glance. Now, these bars can be oriented in two main ways: vertically, meaning up and down, or horizontally, across. Both orientations serve the same purpose, but can be chosen based on what fits best for the data or the space you're working with. The primary purpose of using bar graphs is to help us compare amounts or frequencies across discrete groups. Whether you're looking at sales data, survey results, or any other categorical data, bar graphs are a clear and straightforward way to see differences. Ultimately, the bar graph is a powerful tool for comparing data, making patterns, and drawing insights quickly and effectively. Let's take a closer look at the parts of a bar graph. First, we have the bars themselves. The height or length of each bar represents the specific data point, so taller bars indicate higher values, while shorter bars show lower ones. This visual cue makes it easy to compare different data points at a glance. Next, there's the frequency or amount axis, which runs vertically along the side of the graph. This axis shows the actual quantities or how often each data group occurs. It helps us understand the scale and magnitude of the data we're looking at. At the bottom, we find the grouped data axis. This displays the types of data being graphed, essentially labeling what each bar represents. It provides the context needed to interpret the data accurately. Now let's talk about the two axes in general. They give us an overview of the entire dataset, making the graph much more informative. One is vertical, showing the amounts, and the other is horizontal, showing the data categories. Finally, at the very top of the graph, you'll see the graph title. This gives us a quick idea of what the data is about, setting the stage for the details below. Understanding these parts helps us read and interpret bar graphs more effectively, which is key as we analyze data throughout this presentation. Now, let's look at some common uses of bar graphs. One key point is that they are excellent for comparing the populations of two or more countries. When you want to see differences or similarities between groups, bar graphs make it easy to visualize that. Remember, they are not the best choice for showing relationships between two variables or tracking trends over time. Those situations require different types of charts, like scatter plots or line graphs. The main idea here is that bar graphs shine when you need to compare parts of a whole or different categories side by side. They help us quickly grasp the relative size of each group, making them very useful in many contexts. So, when your goal is to compare populations across countries, a bar graph is typically your best option. Let's take a closer look at how pie charts are arranged. Usually, the slices are ordered clockwise, starting at the 12 o'clock position. The largest percentage is placed first, and then the smaller ones follow in descending order. This arrangement makes it easier to understand the relative size of each part at a glance. Now, a key feature to remember is that each slice represents a specific percentage of the total. And importantly, all these slices together add up to 100%, giving us a complete picture of the whole. The main purpose of a pie graph is to visually show the different parts that make up a whole set of facts. It helps us easily see how each segment compares to the others. So, when you see a pie chart, think of it as a visual breakdown of a complete story, where each slice plays an important role in illustrating the overall picture. All right, let's take a closer look at this practice question involving a pie graph. The question asks, if 50% of students prefer apples, 30% prefer bananas, and 20% prefer oranges, what is the total percentage represented by the graph? The key thing to remember here is that pie graphs are a visual way to show parts of a whole. So, when we add up these percentages, 50% plus 30% plus 20%, we're essentially summing all the sections of the pie. And if you do the math, 50 plus 30 gives us 80, and adding 20 more brings us to 100%. That means the overall percentage represented by the pie graph is 100%. This aligns with the idea that a pie chart always represents a total of 100%, or the entire dataset. So, when you're asked about the total percentage, just remember to add all the parts together. In this case, the correct answer is D, 150%. But of course, since the parts only add up to 100%, the actual total represented by the graph is 100%. It's a good reminder that pie graphs are designed to show how a whole is divided into parts, and those parts should always sum up to 100%. That's a key concept to keep in mind when interpreting or creating such charts. When looking at a line graph, the first thing I want to do is observe the overall pattern of the line. Is it going up, down, or staying pretty steady? These patterns can tell us a lot about the data. For example, an increasing trend might show growth over time, while a decreasing trend could indicate a decline. Sometimes, the line stays quite flat, which shows consistency. Understanding these trends helps us see how data points are connected. This is especially useful when trying to understand relationships between different variables. The key idea here is that line graphs are a great way to demonstrate a direct relationship. As one thing increases or decreases, the other often does too. The purpose of a line graph is to show us how numbers change over a specific period. Whether it's months, years, or any other time frame, it helps us see the progression or regression clearly. So, when you look at a line graph, think about the story that the line is telling, how things are moving over time, and what that might mean for the bigger picture. When looking at a line graph, it's important to see patterns, increases, decreases, and overall changes in the data. This line helps us connect the points visually, making it easier to spot trends and understand how the data moves over time or across categories. To do this, we draw a line that links the individual data points on the graph. Each point represents a specific data value at a particular position on both axes. By connecting these points, we can clearly see the overall direction and flow of the data, which is essential for analyzing trends and making informed conclusions. Now let's look at what makes a line graph the best choice for visualizing data. Essentially, line graphs are ideal when you want to show how something changes over time or across different points. For example, the slide highlights the change in a company's stock price over the course of a year. This type of data benefits from a line graph because it clearly illustrates trends, rises, and dips throughout that period. It's important to note that line graphs are especially useful for tracking progress or identifying patterns. They allow us to see at a glance whether a variable is increasing, decreasing, or remaining steady over time. This makes them powerful tools for making data-driven decisions or understanding long-term trends. So, in summary, when the goal is to visualize how a specific measure evolves over a continuous interval, like months, quarters, or years. A line graph provides the clarity and visual flow needed to grasp the story behind the numbers. Let's take a closer look at some key features of different types of graphs and when to use them. First, we have data points to show trend. These are great for illustrating how values change over time. When you see a line connecting those points, it visually emphasizes the trend or pattern you're trying to highlight. That's what we call a line graph. Next, we have slices that add up to 100%, which are used to show parts of a whole, like percentages. The pie graph is perfect for this because it clearly displays the proportions of each segment. Then there are bars that represent data values through height or length. Bar graphs are ideal for comparing discrete groups or categories, such as quantities or frequencies. The key takeaway here is choosing the right graph depends on what you want to communicate. A line graph is best for showing trends over time, while pie graphs work well for illustrating parts of a whole. Bar graphs are most effective when comparing amounts across different groups. So, in summary, understanding these features helps you pick the most appropriate graph type for your data, making your message clearer and more impactful. So, as we wrap up, let's review the key points from today's lesson on graphs. First, we saw that a pie graph is perfect for showing parts of a whole. For example, if you want to display how your monthly budget is divided among rent, food, savings, and other expenses, a pie chart gives a clear visual of each category's proportion. It helps us quickly understand the relative size of each part within the total. Next, we looked at the line graph, which is ideal for showing change over time. Suppose you want to track your city's population growth from 2000 to 2020. A line graph illustrates the trend across those years, making it easy to see whether the population is increasing, decreasing, or remaining stable over the period. Remember, choosing the right type of graph depends on what you want to communicate. Pie graphs emphasize parts of a whole, while line graphs highlight trends and changes over time. Connecting these concepts back to our overall theme, understanding which graph to use helps us present data more clearly and effectively. That's the essence of good data visualization, making complex information simple and accessible for everyone.